Hello everyone. So for this video, I want to go over section 2.5, determining derivatives at a point. This is actually going to be a pretty short lesson, and you'll even see that the problem set is pretty quick as well. But the concepts in this are extremely important, so let's kind of go over it. So first of all, I've said this a million times. You guys should know this by now, but the derivative is an expression. All right. The derivative is an expression that calculates the instantaneous rate of change, and obviously by that I mean the slope of the tangent line. I should have made more space here, but whatever. The instantaneous rate of change of a function at any given x value. In other words, it gives us the slope of the function at a point. All right. I probably should have done this example first, but let's just kind of like understand that a little bit more in detail. All right. So let's say I were to get some kind of straight edge. I can't find my ruler at the moment, so I'll just use this. And let's say I wanted to know what is the slope of the tangent at an x value of 1. Well, let's see. If I look at an x value of 1, that refers to this point right here. And if I were to draw kind of the slope of that tangent line, so I'm going to try to draw a tangent line like there. It's pretty close. Hold on. Maybe if I do it from this side. I would say that's about the tangent line right there. Okay. Again, if I drew a tangent line there, and I try to figure out what the slope is, well, let's see. I know that it crosses this point, and let me see another point on the graph that I can find. Again, if I look at the rise over run, it rises up 2 over 1. So that's a slope of 2, right? And that kind of makes sense. If I were to plug in 1 into my derivative, this is the derivative already calculated from this, right? If I plugged in 1 into this, then I would get a slope of 2. Similarly, if I would have done, and let me get a different color for this, if I were to find the slope at x equals 2, well, here's 2. That's kind of a point right there. If I drew a tangent line going through there, let's see what I would get. Kind of something like that, right? Notice how I have a tangent line there. Well, if I pick 2 points on this graph, let's see, like maybe it seems to cross there, and obviously that's going to be a point. The rise over run, 1, 2, 3, 4 over 1 is 4, right? So again, you have to understand, and I know some of you are probably rolling your eyes because you already know this, but it's just, I feel like there's always a group of people who are not going to understand this. But you just have to understand that the derivative represents the slope, not exactly the equation, but at the slope or instantaneous rate of change of a graph at any value of x. I plug in any x value in here, and I'll get the slope. Like if I plug in -2, I'll get -4. And you'll see that if I plug in -2 into this, and I were to draw a tangent line for this, right? Again, that slope is going to be down 4 over 1, okay? So that's just some fundamental things that I need to review and I need to stress a lot. So sometimes what the AP exam will do is they'll give you kind of a graph here, and you have to pretty much look at g of x, right, which is just kind of a funky function. It's like almost like a piecewise function, right? And you have to determine what is the derivative at different x values. So if I look at this one, at g prime of -3, bear in mind, this is the original function. If I look at -3, well, -3 corresponds to that point right there, right? Now, this isn't like a curve or anything where you kind of have to draw the tangent line yourself. Like, the tangent line is essentially that line, right? So if I wanted to know what the derivative at -3 is, I got to know what the slope is of of pretty much this whole thing. So again, if I look at this, the slope of this line, let me pick 2 points that are just kind of on here that I can easily find rise over run for. Let me look at this one and this one. It's going to rise up 1 and then go over 2. So up 1 over 2. And that's pretty much the slope for that. All right. Similarly, if I look at point 3, well, at 3, that corresponds to this part of the graph. I just got to look for the slope of this whole thing right here. So, I mean, I just kind of pick 2 points. I'll just use these 2 points. Down 2 over 1. So then that slope is negative 2. And then if I look at at x equals 7, that corresponds to this point. I mean, that kind of just, the slope of this tangent line pretty much just looks like it's rise over run. So 1 up 1 over 1, so 1. All right. It's not too bad. It's pretty straightforward. So just know that, I mean, again, you just have to know that that the derivative, once you see the little tick mark, it represents the slope of the tangent line at any point in the graph. So now for the meat and potatoes of this section, you need to know how to calculate the derivative at a point on your calculator. So up until now, we've been doing a lot of derivatives by hand and doing power rule, product rule, quotient rule, tangent, trigonometric rules and all of that. Sometimes if you're given a question on the calculator section of the exam, it's probably a lot easier and faster to just plug this into your calculator and do all of that. Keep in mind, don't do this. I wouldn't get in the habit of doing this every time, because there are questions on the AP exam that are in the non-calculator section where you have to know those rules in order to find the derivative. But if it is a calculator portion of the exam and they ask you to find the slope of the tangent line or the derivative at an x value, just plug it in your calculator. So let me kind of show you here. So for this first function, we have f of x is equal to the sine of the square root of x, and they want you to find the derivative at x equals 2. So, I mean, I know some of you have the more advanced calculator, and I wish I had one of those with me to show you both calculators, but I'll at least show you with this one because this is a pretty common one that most kids would have. So if you want to find the derivative of this function at x equals 2, we're going to go to math, and then we're going to scroll all the way down to where it says n derivative. Okay, so we're going to find the derivative, and then we're going to put in the function. And here you have to be careful with your parentheses. I'm going to put sine of the square root of x, right? So I'm going to close the parentheses for the x, and then I also want to close the parentheses for this initial one next to the sine. All right, so now I have the sine of the square root of x, and then I'm going to take the derivative with respect to, I'm going to put a comma x, and then after that, I'm going to say what x value I want to find the derivative for. All right, so you put the function with respect to whatever variable you're looking at. It's mostly going to be x, and then the x value that you want to find the derivative for, and that's the answer, 0.05513. So I bet you if you actually took the time and took the derivative of all of this and plugged in 2, that's what you would get. All right, so yeah. I'm just going to go ahead and move on. All right, so now let's do this one. Now we want to find if the function of that, find the f prime of 1.3. So let's do it. Math, scroll down to n derivative, and let's put this. So we have the natural log of 1 divided by, and I'm going to put 5 minus x in parentheses. Please don't put 1 divided by 5 minus x. The way that the calculator would read that, it would say like 1 over 5 minus x. That's how it would read it, and that's not the same thing as 1 over 5 minus x. So let's put 5 minus x in the parentheses. 5 minus x. So I'm going to close the parentheses for this one, for this 5 here. Then I'm going to close another parentheses for that one, for the one between the natural log and the 1. And that's the function. Comma with respect to x, comma 1.3, and there you go. 0 points, and let's do 3 decimal places because that's common for the AP exam. 0.270. So I should say f prime of 1.3 is equal to that, and over here I should say f prime of 2 is equal to that. All right, and then here's here's an example that we should be familiar with. Hopefully we don't mess this up. If it says write the equation of the tangent line, so they're not just asking for the slope, they're asking for the equation of the tangent line, right? And of this function at x equals 1. Well, obviously we need to have an x and a y value for an equation. So x is 1 and y is going to be, let's see, if I plugged in 1 into this, I have the square root of 1 over 1 plus 1, so pretty much the square root of 1/2. You know, I'm just going to use decimals here. Square root of 1/2 is 0.707. Okay, so we have an x, we have a y value, Then if we do the slope, all right, well, the slope, that's determined by taking the derivative at that x value. So let's go ahead and do that. Math and derivative of, let's do the square root of 1 divided by parentheses, x cubed plus 1. So I'm going to close this parentheses, then I'm going to close this parentheses. And then with respect to x, at x equals 1. So there's the slope. Let me double check that. Did I do something wrong? Oh, shoot. This was x, not 1. X. There we go. That's right. So now I have negative 0.177. That's going to be my slope. All right. So now we just kind of do the equation of a tangent line. Y equals mx plus b. I'm going to plug in my x, y, and m value. So I have 0.707 is equal to negative 0.177 times 1 plus b. So if I work out all the math, I end up with b is equal to 0.884. And then, so if that's my y-intercept and I have my slope, my equation of a line is y is equal to negative 0.177x plus 0.884. All right, and there you go. All right, so now that's essentially how you use your calculator to find the derivatives at a point. The next thing you should know for this section is estimating the derivative from a table. So a lot of times what they'll do is they'll give you a table, and they want you to find the derivative at a specific point, right? But they don't give you like the information for that point. So essentially, just to kind of give you sort of an understanding, like I don't know what this function looks like, but I'm just gonna make it up. All right, let's say that we have just some function kind of like this, right? And they give you an x value of 2 and maybe 4, and then they want you to find the instantaneous rate of change at x equals 3. So here's the thing: if I wanted to find the instantaneous rate of change, then that's the slope of the tangent line, right? But if they don't give you any information for x equals 3, the next best thing, and it's not ideal, but the next best thing is to look at the x values that are near it, right? And then finding the rate of change between those 2 points, and that's a pretty decent estimate. Is it perfect? No. But they just want an estimate, right? An estimate of the derivative at x equals 3. So really, if they don't give you x equals 3, pick the 2 points that are nearest to it. So we know that 3 is right here. The two nearest to it are 2 and 4, and then just use find. Oh my gosh, my computer. And then just find the rate of change between those two. So just as a reminder, rate of change, we have to do f of 4 minus f of 2 divided by 4 minus 2. Which is essentially equal to f of 4 is 10 minus 3 over 4 minus 2. So that is 7 over 2, or 3.5. Okay. And let's kind of get in the habit of writing units, right? So if we're doing miles over hours, so like the values on the top are going to be miles divided by hours. So we'll do miles per hour. Miles per hour. Okay. I feel like I should be doing more unit stuff, especially so I know a lot of you have to take the SAT, and I know units are a big thing on there. All right. So using the table, estimate W prime of, I meant to say 100. Sorry. Just fix that on your papers. Using the table, estimate the derivative of W at x equals 100 and show the work that leads to your answer. Well, 100 is right here, right? Which we don't have a value for, but let's pick the 2 values that are closest to it and then find the rate of change between those 2. So we'll do f of 120 minus f of 80 divided by 120 minus 80. So f of 120 is 500 minus f of 80, which is 700, divided by 120 minus 80. So you essentially have negative 200 over 40, and that gives you negative 50. And let's get our units right. So if it's gallons per second, right? So we pretty much have gallons per second, right? I mean, those of you who have taken physics before probably know that that's just gallons per second squared, but, you know, why is it second squared? You just, again, flip, gallons per second, and then times the reciprocal of the bottom. So it's going to be gallons per second squared. And that's your answer. All right. So again, I mean, wow, I don't know how I managed to make that 15 minutes. But anyways, it was supposed to be short. And hopefully it was simple enough. Now you have an extra tool in your toolbox to use your calculator to find the derivatives. Again, on this next test, there is going to be a calculator and non-calculator section. So make sure that you know how to do both methods. All right, so hopefully this was helpful. And if you need any help or have any questions, just let me know and I'll help out. Take care.